right, and good morning everybody, and welcome to episode 42 of the MakerBot Chats. My name is Felipe. As always, it's a pleasure to have you guys here. 42 episodes, that's quite a big amount, I guess. More than we were expecting at the beginning of this also. Thank you guys so much for joining as always. We got an interesting one. It's always going to be good to go sort of back to basics, I would say, with one of the most standardized 3D printing filaments out there, ABS. But we'll talk about some of the differences and key elements that make it special, specifically when working with the Method 3D printer. So yeah, let's get right into it. I'll start by just taking you guys through the specs. And as you might know, here we go. Live from New York, I guess. So if you hear any sirens and honking, that's the reason. But in any case, let me get rid of this camera here. Here we go. Going to our website, if you scroll over materials or hover over materials and under polymers, you'll see ABS. ABS, as you guys might know, it's one of the most popular 3D printing materials overall. It's also one of the most popular injection molding materials, which is one of the reasons why it's been so popular with 3D printing. The easy standard reference is going to be Lego, right? So Lego bricks are made with ABS, and it's one of the most commonly injection molded polymers out there because it's particularly strong, particularly stable, has good resistance to UV light, overall good chemical stability. So that makes it great for extrusion processes, for injection molding processes. And in the case of 3D printing, well, extrusion, it's essentially what you're doing, right? You're extruding that filament through layer by layer and forming a shape. So super popular for injection molding, as I was saying before, and it's going to require a high temperature to deform, and that in turn means that it's going to require also a high temperature to print, right? So when printing with ABS, you will need a system that will provide either heated build plate, which is okay, for the first couple of layers, or preferably a heated environment. So that's what the Method does, right? It's a heated chamber that essentially encloses that print in a 100-degree Celsius chamber, and thus allows it to slowly cool down, right? So it's not immediately going down to room temperature, but rather slowly cooling down. ABS is going to be prone to warping, especially when it cools down really fast. So if you're not using something that really controls or is able to control the temperature, it's going to be harder to print with it, right? So it's usually above 100 degrees Celsius. In the case of the Method, the platform itself, it's going to reach close to 110 degrees Celsius. And the chamber, it's going to average around 105. I'll take you guys through the slicer in just a second. But yeah, really noble material, I would say. As long as you're keeping those temperatures high up, you'll be able to print with it without much of an issue, right? Regarding compatibility, specifically within Method, we will be using only the Method X. That's because, as I was saying before, you need a printer that will take you all the way up to 110 degrees Celsius. So with Method, the maximum heating temperature is going to be 60 degrees. With Method X, you can go all the way to 110. And that makes it ideal for ABS, right? Initially, it was actually the reason, or one of the main reasons behind the design of Method X. There's actually differences in hardware that allow you to reach those temperatures. It's not just that it's running for longer, it actually has more power to it. If you compare the Method and the Method X power consumption, with the Method, you're talking about close to 40 watts. With the Method X at its peak, it goes to all the way to 400 watts and close to 800 for the Method X when it's heating up, right? So it does pull a lot more current in order to actually be able to reach that higher temperature threshold. Now, the other thing that you will need to use, and I'll switch over to my side camera here for a second, are the two extruders, right? So we have a dedicated extruder for ABS. That's our 1XA extruder. It comes standard with all of our Method printers. Our Method X printers. The reason for that is that, essentially the hardware is a little bit different. It's also a dedicated extruder because, as we mentioned in the past, it's important to have, I would say, the analogy keeps going, or is still that idea of drill bits, right? You use a drill bit for wood, you use a different one for concrete, you use a different one for metals, and that's the same idea here. So the 1XA extruder will be able to handle most of the higher temperature polymers. That includes ABS, ASA, polycarbonate, and so on. And the 2XA, that's the companion extruder. So you have one extruder that's for model, so as you can see here, the model extruder or the 1XA extruder, and a secondary extruder that's for support. Let me try to highlight it here. Here we go, support, right? The support extruder is going to essentially, well, as the name suggests, right, the one that you'll be printing the support with. And in the case of ABS, we are working with a particular type of support, and here it's one of my print samples, particular type of support called SR-30. SR-30 is a proprietary filament from Stratasys, that's our partner company, that will allow you to dissolve the supports after it's been printed out, right? So as you can see here, the black component of my part, that's my part, right? And the white one is the supports. The supports are essentially creating this bed, if you want to call it that, that allows me to print these overhangs, right? If I had no supports underneath this section, then my part will be floating in thin air and in turn will just droop and zag. I know that there's some printers that have a reasonable amount of bridging distances. So bridging means how long will a print be able to, the nozzle or a printer will be able to extend the filament between 2 points, essentially like a bridge, before that bridge sags. That's a nice trick, maybe, but if you go for distances over 20, millimeters, I think it's just kind of like not ideal. You really do want to be using supports because that's what's going to guarantee, and in the case of this part, you'll see it here immediately, that's what's going to guarantee, let me bring my macro lens, the proper finish on the part, right? So as you can see here, this part is really, let me bring the light here, super smooth, right? So look at the floors on this part. They're incredibly smooth. There's no way that you'll be able to do that without supports. And with ABS, one of the tricky things is that it's not going to want to attach to any type of support. So for example, if you're familiar with PVA, the traditional water-soluble support, that's not going to work with ABS. So you'll have to use one of two options, either a breakaway option, which would look something like this, right? So this is breakaway, but still using SR-30. I'll talk a little bit more of that in a second. But you could use breakaway supports with ABS. That essentially will print both your supports and your part out of the same material. So instead of these being white and black, you would see these being black, and then once the printing process is completed, you would go in and manually remove those supports. The reason why it's called breakaway is because most systems, that includes MakerBots and others, will print this sort of perforated structure or scaffolding, right? That essentially diminishes the strength of the support system or the support section to make it easier for you to manually remove those supports out of the part. However, there are some cavities. If you look at, this is a bicycle pedal, by the way, that I printed out on my method over here. If you look at the insides of the part here, you'll see that there's still some support inside. So some cavities are simply not going to be easily accessible or directly accessible mechanically, right? That's why having the option of soluble supports, as these three parts suggest, becomes really important and really useful, because I don't have to be thinking about, how am I going to remove these supports? I can just go ahead and print my part, dunk it in a wash tank, and have the supports dissolved regardless of the location, right? Because the water is going to permeate throughout the part and in turn dissolve all of the supports. It doesn't really matter how complex my part is, I am still going to be able to remove those supports. Like, coming back to this part again, you can see how the insides of these pipes here also have supports, right? So I was able to remove just by wiggling around, this sort of first layer or base layer of supports here kind of cleanly. But any cavities, any sort of internal supports that you might be using or internal cavities of the part that you might be that might require supports or soluble supports. That's what happens inside of these pipes. So the inside of these legs are actually hollow, right? And as you can see by suggested here on the part here and here, it's all filled up with soluble supports. If I'm not able to mechanically access those using breakaway, with a standard single material printer, it's just not going to be an option for more complex parts, right? So you might be able to get away with something fairly simple like this wishbone print, right? That only requires supports on the base of it, and I might be able to just peel it off and mechanically remove it. And by mechanically, I mean just using pliers. We do have a set of pliers that comes with the Method post-processing kit. But yeah, it's possible to remove the support materials in some cases without having to use the soluble solution, the soluble alternative. But it's definitely going to be much more flexible to have that soluble material, in this case SR-30, and to round things up, that works with our Extruder 2XA dedicated for SR-30, plus our 1XA, which is the one that's going to be working with ABS, right? So wrapping things up here in our website, you'll see that we do have a few color options for ABS. If you wanted to use multiple colors, I got over here just a sample of black filament. I'll talk about it in a second. Generally speaking, I like to print in a single material. If you wanted to highlight a part, if you wanted to have a different option, that's certainly out there for you. Orange, red, gray, black, and white are possible if that's what you'd like to do. And as I said before, it's going to be using Extruders SR-30 material for support. The accuracy on these parts is just phenomenal. It's going to be plus or minus 0.2 millimeters. So that's about 7/1000ths of an inch. Really, really, really spot on. I think we've been printing with this material for almost as long as MakerBot has been around, so that's close to 10 years. And we've learned a lot, in that. It's also coming from our partner company Stratasys. So we do know a thing or two about printing with ABS, and now ABS with soluble support. So the parts are going to be incredibly accurate. They are going to be fairly strong. It's ABS, as anybody who has stepped on a Lego brick will tell you. Those parts are fairly stiff, right? So great material for stiffness, great material sometimes for outdoors applications, although there's a variation in ABS called ASA that might be better for outdoor applications, but still pretty good resistance to the humidity, the elements to some extent, right? I would still go to other options, maybe if it's something that's meant to be outside or exposed, but still pretty stable material, great option to print. And running through some of the specific tech specs, the heat deflection, 84 degrees Celsius, pretty high, almost close to boiling temperature for water. The flex modulus, 77 megapascals, tensile strength, that's also 43, fairly high as well. So as you can see, it's a fairly stiff material, right? I would say it's stiff, it's strong, it doesn't really want to bend. When it does, it's not going to, bend easily. If you bend it, it's probably going to snap. So the failure of these parts, it's not through deformation, so it's through plastic deformation, but rather it's kind of more brittle in deformation, right? So if you push it past its threshold, it's just going to snap, right? So these parts are really, really strong until they're not, and they just snap. Still, they have a high tolerance for both impacts and just generally applied forces, or directly applied forces, but something to note, right? It's just going to be very stiff, strong, but at the same time, once you go to above that threshold, brittle material. Coming back to these parts here as well, well, actually, I have a few applications that I may want to cover for you guys. And as always, just a reminder and a quick check on Alejandra's on the back end, capturing all of your guys' questions. If you have questions right now and you're watching this live, you can go ahead and write them on that right-hand chat section. If you're looking at the recording of this, you can go ahead and write the comments on the comment section down below, and we'll be sure to answer them later on. But for now, some examples of the applications, end-use parts, because of its great accuracy. We've seen people do short productions or short runs with ABS. We've seen people also use it for manufacturing tools. In this case, what's highlighted here, it's a sander, it's the head of a sander that actually the vacuum for the sander, if that makes any sense. So they have a CNC machine, and the CNC itself had a vacuum element, and that element had the opportunity or the possibility to design. They had the opportunity to design the head unit for that vacuum, and this is the end result. Functional prototypes also, right? So you can, if you're planning on doing something like what I have here in my hand, let me make sure that I'm showing it correctly. Here we go. So this is another attachment for a robotic arm, right? This is made by one of our, case studies, All Access Robotics. They wanted to do a dual dual attachment point for one of the robots, right? So this goes against the robot, and here they have two connector elements to use different tools, so the robot could toggle between two tools. And again, fairly strong, really great for prototyping, especially like say, if you wanted to test something out before running into the production, it's great because you're essentially prototyping with the material that might be used for the final injection molded part. So yeah, another great application for ABS on functional prototypes. I'm going to take you guys quickly through some of the parts that I've got here. So, well, before I do that, I have the parts here, but I'll just wrap up with the system. So you'll need the Method X, you'll need Extruder 1XA, 2XA, and the filament itself, which I have a sample of right here. This is ABS in black. As you can see, it states the type of material that it is, the fact that it works with the Method X series. I'll bring it closer. The spools themselves will come at around 1.43 pounds per spool, and each spool will also have, let me open this for you guys, one of these core elements which contains two things, or two big things, right? First of all, the inside of this part is, and you might be already able to see it here, it's going to have a desiccant packet in it, right? So this silica gel that keeps that material dry and essentially absorbs any moisture that might be present in the environment, or might just seep into your material. So it's always there with your spool. I think that's one of the big difference or key difference between Methods and MakerBot spools versus other types of off-the-shelf or kind of like white label spools. It's always there, it's always protected, and also this white label here, it's actually an RFID tab. The RFID tab is going to enable the printer to detect the type of material that you're using, in this case, of course, ABS, and track the usage. So that essentially allows the printer to know how much material is left, how much material will be used for each print, and in turn, give you better control over your material usage. So that's it for what's needed. Method X, the two extruders, the material, of course. And now let's talk a little bit about the printing process. So I have a few parts here that highlight different types of prints that you might want to be or might be doing with ABS, right? The first one I've already discussed a little bit. So it's this valve component. It's actually, it was meant to be, suction cups for a robot arm as well. So you could see how here's kind of where the vacuum would sit. These three element cylinders are the attachment points, and then these three external elements would be where the suction cups be placed. So the suction comes from the center, is distributed amongst or through these arms, and it's able then to pick different parts that the robot might be picking itself. So fairly straightforward part, but as you can see, really important to use the support structure here because of this massive overhang. So we're talking about close to 4 inches, if not more, here of free span. So that's why you would need the supports. In this case, it was easy for me to remove the tapered supports, but everything that's inside of the part will need the wash tank. And the wash tank is essentially using water plus solving agent, which is called EcoWorks, the EcoWorks tablets, and because of the combination of the low pH of the EcoWorks and the water and a heating element, so it's actually heating the wash tanks usually heat the water up to about 60 degrees Celsius. That causes the SR-30 material to dissolve and frees up your part from the supports. So that's part one. Part two, this wishbone. This is actually a sample part from one of our case studies from Mirage Motors. We released that lately. It's well, actually not lately, but released that about 2 or 3 weeks ago. Really exciting case study, a lot of fun working with those guys. And again, kind of the same, right? So it's a wishbone, it's a mirror part. You can imagine how here underneath you have the same sort of material reduction that's happening here on the top. And because of that, you would need also the support material. There's a few cavities here, so here on the attachment point, here as well on these cylinders, here, on the tips of the wishbone. So fairly straightforward. I would probably be able to just remove this support manually. You can hear it cracking already. Here we go. Let me bring it closer to the mic. Right. So I could probably remove this by hand without much of an issue. But again, just better to keep in mind that SR-30 will actually enable you to print much more complex parts, which I think is what this highlights the best, right? This is a bicycle pedal. I have, where is it? Here we go. So I have the part here without supports, with supports, as you can see, right? There's no way, well, you could, and actually this part I printed without support. So you can see how the part drooped a little bit. So if you really want that proper finish on your parts, you will want to use the supports. And the second thing that this highlights is the breakaway support. So in method case, as I said before, you're not only being able to use the soluble material, but you can combine it with the breakaway mode and in turn create supports that are both soluble and at the same time really easy to remove. So you could, once the part is printed, remove the supports mechanically, so I could just grab pliers and get them out of my part, for the most part, and then drop the remaining few supports into the wash tank solution and then have a reduced amount of dissolving time for the part to be ready to use, right? So that's one of the benefits of using SR-30 with the breakaway mode. And what I'm going to show you right now is that also changes. Here, let's go to my cloud print window. It's also going to change the way that the time that my part is going to take to be printed. So in this case, I've just sliced this part using, I think, yeah, here we go. This is using actually the tapered column, the column support, so straight up instead of the breakaway. It's going to be taking about 16 hours to print, right? If I bring it to the queue, I'll see it here in just like 16 hours. If I was using the straight up column supports, I would be looking at about 17 hours for the printing process to be completed. Here, by the way, I'm using CloudPrint, our slicing software. It's completely free. You can go in cloudprint.makerbot.com and try it out. You don't need to have a printer or MakerBot printer to use it or to test it out. It's just free to use, already out there, and it's essentially our cloud-based slicing software. If I bring one more of these, where is my pedal? Because I want to show you guys how does that process look like, right? And as you can see here, well, I'll open it in a new window in just a second. From 16 to 17 hours, depending on the type of support that you're using. And the support selection happens right here. So as you can see here at the lower right side hand corner of my window, I can choose between breakaway model material. That, as I said before, is going to be printing both. Oh, and by the way, here, just need to change it to ABS. The reason why it's not detecting it is because I'm actually using my labs extruder on this machine, and I actually have metal loaded right now, but in any case, I can change that. And just here, okay, selecting the support type, breakaway model material, that's going to print both the model and the part out of the same material. I'll slice it for that one in just a second, just to see how fast or how much time you would save with it. However, this might work for simpler parts. For more complex parts, it's just not going to be ideal. You will want to use the soluble supports. Second option is dissolvable column. That is using our soluble support and extruding it straight up onto the part. Third option, dissolvable tapered. So it's kind of what you're seeing here, where instead of the material coming up straight up into the part, it's going to slowly taper upwards as it grows. That saves material, saves time. But it does depend on the application, depending on what you're trying to do. And finally, the breakaway support material, which is what I mentioned before. It prints with this sort of hollow-like structure that is going to be easier to remove and easier to work with after the fact. Now, if it's a very complex part, I wouldn't recommend the breakaway support material, just because it can get a little bit hairy sometimes, especially for more complex parts. Like, you know, if you have a tessellation like this one, you might not want to use that. But let's go ahead and choose breakaway model material, print preview, and see how long it's actually going to take for this part to be printed. As we mentioned before, column supports is going to be taking about 17 hours. Tapered support, soluble support, is going to be about 16 hours. And I'm expecting this one with breakaway model support to take maybe even 15 hours, because it's going to, you know, save a lot of time by not having to toggle between the materials. But again, the downside of it is that if you're printing something that's fairly complex, you might not be able to remove all of those breakaway supports from the inside cavities of your part. And with that, while this slices, I'm going to, here we go, ready by Wednesday. What's the, oh, it's still slicing in the background. While this finishes, I'm going to start running through some of the questions that I've had here in the chat box. What solution is used to dissolve SR-30 support after printing? So that's water plus the EcoWorks tablets. The EcoWorks tablets work very similarly to a detergent, changing the pH of the water and in turn altering the composition of SR-30, dissolving it in the water. Does ABS plastic break easily? What are the disadvantages of the material? It doesn't break easily. I think it's as I said before, it's a very stiff and strong material. One of the disadvantages might be that it's, you know, you do need a dedicated printer, so like the Method X. What else? I don't know. I think all in all, it's a pretty good material to print with. Really stable, you know, fairly strong and straightforward to print. So not necessarily downsides to it, other than, you know, it might not have some of the specialized properties of carbon fiber or a nylon or a PETG for chemical resistance. So that's kind of like, it's more of ABS standard for everything application. If you have something more specific in mind, you might want to look into a more specialized plastic. Let's see, where are we here on the slicing? Well, while the slicing finishes here, I'll just bring this back to my view. Third question, what are the best print and bed temperatures for ABS? As I said before, and this is also related to the heat deflection temperature of the material is going to withstand, you know, all the way to 85 degrees Celsius before it starts to be malleable. That in turn means that you have to go above that value in order to be able to print it. So we are printing ABS in the extruder at around 250 degrees Celsius, and the bed itself gets to 110 degrees Celsius, the chamber as well, to kind of keep that material warm and happy as the printing process is completed. Is ABS safe for food? I would recommend something different, like a PETG, right? Maybe even a PLA. ABS, not really. And you know, especially with 3D printed parts, no matter the resolution that you're using, all of the layer lines, the micro separations between the layer lines, will create cavities that bacteria can use to grow. So generally speaking, 3D printing parts, I wouldn't use it to continuously eat out of them, right? Maybe for the prototype, for the one-off, yeah, that's completely fine. But if you are planning on having something, you know, for food preparation or for continuous use and consumption, not necessarily. Is it safe to print ABS indoors? This is a great question, and actually it is, but it depends. Now with the attachment or the inclusion of our, let me bring it here on the website, but the inclusion of our clean air, oh, by the way, this is done. Trying to see, I'll just queue it and then see how long it takes. But if I go to our site with clean air, right? Clean air is the attachment that essentially filters out any remaining particulates being created by the printing process. Their, you know, method is already an enclosed system, so it's really good at keeping the volatile compounds inside, But the cleaner, it's an active system that essentially helps or creates an even higher level of protection against volatile compounds. We have the data already. It's going to be published in a few months, and it's just amazing, right? Qualitatively, I can already say it's great to print with, because it does reduce a lot of the odors that might be coming from the printer. And quantitatively, we also have the data that, as I said, it's about to be ready to be published. But that makes it super safe to print indoors. Again, I wouldn't put, as always, because I get this question often, I wouldn't put these printers in a closet. But yeah, if you're printing in an office environment, if you're printing in a studio setting, it's completely fine. Let's see. Oh, wow, half the time. So yeah, a lot of time saved by using breakaway models. So 8 hours versus 16 versus 17, right? That is breakaway, tapered, and column supports. That toggle between materials is going to consume a lot of time. But if your part is complex enough, if it warrants it, you might want to do it anyways. Let's see, a couple of last questions before we wrap up. Oops, lost my document here. Is ABS or polycarbonate stronger? Polycarbonate would be stronger, I believe. ABS is just easier to print with. How do you remove moisture from an ABS filament? From the filament itself, we do have a drying cycle on the printer that you could use if you wanted to do so. But generally speaking, you would just put it in the chamber. The chamber heats up. You can add the desiccant packet itself, and that'll in turn absorb a lot of the moisture. But yeah, with that, I think I'm running out of time. As always, thank you guys so much for joining us today. If you have any more questions, reach out at hello@MakerBot. Felipe at MakerBot as well, and at MakerBot both in Twitter and Instagram, and we'll be happy to answer those. But for now, thank you guys so much for watching watching us, sorry. And yeah, we'll see you next time. Have a good one.